Good afternoon, everyone, for joining me in the journey of improving the output of large language models using reinforcement learning. Large language models like the GPT family are really smart. They have a lot of knowledge of the world and they help us in performing our everyday tasks. They're more like a friend, but apparently they lack the very essence of being a human, and that's called emotions. Large language models do not understand our feelings, our emotions. So my talk today will be focused on how do we make LLMs more human-like. Now, everyone here has interacted with a chatbot, be it ChatGPT or Copilot or any other chatbot. Chatbots are everywhere, and everyone is using them. And they do a really good job in answering our questions. But we all have had frustrating experiences where we've had to paraphrase our question multiple times to get to the desired response. And that happens because a chatbot is unable to understand our feelings, our emotions, our mood, our expression. So a chatbot is basically like your husband. It needs to be explicitly told what needs to be done. Now, you could argue that sometimes paraphrasing is also required with humans and husbands. Well, I do not disagree, but I have two arguments here. Firstly, it is less common with people that you regularly interact with. And secondly, chatbots are AI. They have much more knowledge than an average human being. Why do we still need to paraphrase our question multiple times to get to the desired response? Let me start with some basic terms that I will be using throughout my presentation. A prompt is the input question that you ask your chatbot. So if you're asking ChatGPT to create you an itinerary of France, that's your prompt. The answer that you get back from ChatGPT is your response, which in this case should be an itinerary of France. An LLM or a large language model is an AI model that contains millions, sometimes billions of parameters. It encompasses in itself the knowledge of the world. LLMs are the brains behind any chatbot. Let's look at the agenda. I will start by explaining what iterative prompting is and why should you care. What does it mean for a user? What does it mean for the industry? Then I'll move on to explaining what conflict exists today. Then I'll talk about my research, which is one possible solution to iterative prompting using reinforcement learning that's targeted towards making large language models more human-like. This is an ongoing research for me today, as I am a senior principal research scientist with Dell. It's still in progress. Okay, so this is me having a conversation with a chatbot. I asked my chatbot, tell me the vowels in the capital of California. It comes back to me with an answer saying, the vowels in the capital of California are A and E. So hang on, the capital of California is Sacramento, and my chatbot has clearly skipped out on O and is giving me a wrong answer. So what do I do now? I paraphrase my question. Now I ask my chatbot, tell me the capital of California, and then tell me all the vowels in it. This time, it comes back to me saying that the capital of California is Sacramento, and the vowels are A, E, and O. Well, this is the right answer. But what it had me do was break down my question into smaller chunks. Now, why exactly do I have to do that? Chatbots are smart, and this is a very simple question. This problem intensifies as the problem statement becomes more and more complex. Chatbots expect users to do iterative prompting to get to the desired response. Now, there are certain solutions out there that do some sort of prompt refining for us. They basically take in a user's prompt and then provide a fine-tuned prompt which is more likely to get towards the correct response. We have automatic prompt tuning that takes in a user's prompt, uses a database and an example to come out with a fine-tuned prompt. We have adaptive prompting or chain of thought, which basically breaks down a bigger problem statement into smaller chunks, like what you saw in the Sacramento example. Then we have directional stimulus prompting that adds a stimuli to the prompt to guide it towards the response. Now, there are certain challenges with these approach. They can be compute heavy, especially if you're looking to add a stimuli to the prompt. They require larger models. Well, we all know that larger models usually do a better job at answering our questions, which again leads to the first problem, compute heavy. Additionally, these methods evaluate the prompt in isolation of the response. The response that is generated from the prompt is not used to evaluate the prompt at all. This leads us to our conflict. Now, you could say that just go ahead and use bigger models. They do a much better job. They are much smarter. Why do you really want to struggle with using smaller models when you have bigger models out there? Well, believe it or not, unlimited compute does not exist. Compute is always an issue, especially in the industry. We all want AI on the smallest devices with the lowest latency at the lowest cost. Hence, we need smaller models. Hence, we need quantizations. This takes us to my research topic. How do we enhance the quality of our prompt using reinforcement learning? Now, 3 things to be kept here in mind. We need quantized models or smaller models because we want to save on the compute and we want to save on the cost. We want lower latency. We cannot expect the users to wait for a very long time to get the response. And we do not want the users to do any sort of iterative prompting. We want our AI agent to be able to understand the user's context and then produce a response. Now, how would we achieve that? Okay, so this is Penny. She is ready to start a productive day, and there's a lot that she wants to achieve today. As she opens her laptop, she encounters an issue. Her computer has crashed. She needs help, and she does not look happy. Not to worry, we have Jarvis to the rescue. Jarvis is our AI agent that will be helping Penny to solve her device issues. Now, how will exactly Jarvis do that? The first step to resolve Penny's issues is to be able to refine the input prompt. Now, Penny had a very general prompt. My computer has crashed, help. This has absolutely no details of what the actual problem is or what the actual error code is. So the first step is to use a prompt LLM to refine the input prompt and try and add more details to it. So we use a prompt LLM that refines the very vague input general prompt and gives us refined prompts. So we have 2 refined prompts here. My computer has crashed and shows a blue screen, and my computer is giving an error code along with the error code. Now, these refined prompts have much more details about what the problem or what the error code is. The next step is to score the refined prompt. For that, we take our input prompts that go through a reward LLM that provides a score to each generated prompt. In this case, it has provided a score of 4 to prompt 1 and 2 to prompt 2, assuming that the scoring is between 0 and 5. Now that we have our fine-tuned prompts, it's time to generate a response from the prompt. For that, we take our prompts that go into a response LLM that generates a response for each prompt. Now that we have generated our responses, it's time to evaluate the responses. For evaluation, we take each response that goes through a reward LLM that evaluates our response on multiple criteria. We have sentiment that ensures that the generated response captures user sentiment and is in accordance with the user. Answer relevancy to ensure that the generated response is relevant to the input prompt. We have fairness to try to ensure that our generated response does not have any integrated bias in it. Clarity to ensure that the response is clear and is easily understandable by the user. And faithfulness to ensure that the generated prompt is factually correct. Now, having multiple evaluation criteria for the response instead of just one ensures that the response is not overfitted on any one criteria. Additionally, having elements like sentiment and fairness on the response ensures that we are tailoring our responses to be more human-like and to be less automated. Now that we have the score of the fine-tuned prompt, we have the score of the response on all different criteria, it's time to calculate the total score, which is a combination of the prompt score and the response score on all different criteria put together. In this case, a score 1 for the first combination and a score 2 for the second combination. This is when Penny receives a response. In this case, score 1 is more than score 2, so Penny receives response 1, and she is happy. Now remember, irrespective of Penny providing a very vague prompt, my computer has crashed, help. Jarvis was able to take in the vague prompt, fine-tune the prompt, come up with a better prompt, and then generate a response based on the fine-tuned prompt. Now that Penny's happy, it's time for Jarvis to get to work. Jarvis wants to improve Penny's experience in an iterative manner. It wants to provide more personalized responses to Penny. It wants to understand Penny's context, emotions, feelings over time, and become a friend to Penny who she can reach out to whenever she needs help. Now to becoming a friend to Penny, the first step is to update the prompt LLM. The prompt LLM was refining Penny's input prompt. So we had a very initial prompt, my computer has crashed, help. Prompt LLM was fine-tuning the input prompt and providing a list of prompts that has much more details into what the actual problem statement could be. To do that, we use reinforcement learning. So we pick up the prompt and the response that has the total highest score. That means the score of the prompt and the response on all criteria put together. In this case, score 1. We extract just the prompt piece of it, put that into an algorithm to update the weights of the prompt LLM in an iterative manner. The next step is to update the response LLM. The response LLM generates responses from the fine-tuned prompts. In this case, again, we use reinforcement learning. So the response LLM is actually refining or generating responses based on 5 criteria: sentiment, answer relevancy, clarity, faithfulness, and fairness. So to improve the response LLM, we again take the combination of prompt and response with the total highest score, in this case score 1, which goes into an algorithm in which we iteratively update the response LLM. This will ensure that the responses that are generated from the prompts have incorporated in themselves all the criteria that we talked about, and iteratively over time, the responses are more human-like, and they capture the user's sentiment and become personalized over time. Now that we have updated the prompt LLM, we've updated the response LLM, it's time to update the reward LLM. The reward LLM is actually the one that is scoring the fine-tuned prompt and is scoring the response on all 5 criteria. It's important that the reward LLM continues to do a good job and scores the better responses higher. To do that, we need to understand how well is the reward LLM actually performing. So we take in the response, and that is where we start including some of the human feedback. So we evaluate the input response on 3 parameters: human feedback, which could be a thumbs up or a thumbs down when the user is actually interacting with the AI agent. Then we have follow-up questions, which is trying to understand if the user is actually interacting with the agent, and the sentiment of the user when the user is in interaction. We use these 3 metrics to update the reward LLM. This will ensure that the higher scored responses are the ones that capture user sentiment. They capture user feedback. They become more personalized over time. Now that we have solved Penny's problem, Jarvis and Penny have become friends. Jarvis does understand Penny's context, and Penny does not have to provide all details to Jarvis. Iteratively, it understands her feelings, her emotions, her context, and starts getting more personalized over time. So Jarvis and Penny have now become friends. Let's do a quick recap. The first thing that we did was generated fine-tuned prompts from the input prompt using a prompt LLM. So we took the very vague input prompt. We used a prompt LLM to refine input prompt. Then we scored the fine-tuned generated prompts. Then we generated responses from the fine-tuned input prompts. Then we extracted multiple criteria from the response. And those multiple criteria were sentiment, answer relevancy, fairness, faithfulness, and clarity. Then we calculated the total score, which was the score of the prompt and the response put together. This is when Penny receives the first response, which might not be the best response, but we still have reinforcement learning that's running after this that will ensure that iteratively, Penny gets a more personalized response. Then we started updating the LLMs using reinforcement learning. So we updated the prompt LLM. This will ensure that the quality of the fine-tuned generated prompts from the input prompt are iteratively better over time. We update the response LLM on 3 criteria: human feedback, follow-up questions, and user sentiment. And then we update the reward LLM. Let's look at the advantages. Having multiple evaluation criteria instead of just one, and having a combined score of the prompt and the response will ensure that there is a lesser chance of reward hacking. The prompt LLM and the response LLM will not be able to hack themselves according to the reward LLM. We can use highly quantized and smaller models because each of our LLMs is performing a very specialized task. So we have an opportunity of fine-tuning and quantizing our LLMs to perform just that one specific task. The user will not have to do any sort of iterative prompting because now the AI agent understands the user's context, emotions, and is improving itself iteratively over time. The prompt, the response, and the reward LLM are improving iteratively over multiple and different criteria. With that, I'd like to thank you all for your time.